Okay, straight on to question 3. Probability distribution of a random variable x is shown. There we've got the distribution. Find e of x and variance of x. So e of x, in order to do that, we need to do, where are our values? 1, 3, 5, 7. P x equals x, 0.4, 0.3, 0.2, 0.1. E of x is sigma x p x equals x, which is 1 times 0.4 plus 3 times 0.3 plus 5 times 0.2 plus 7 times 0.1. And if we bung that into the calculator, we come up with 3 as our answer. The variance of x is the expectation of x squared, take away the square of the expectation of x. So that is, e of x squared is 1 squared times 0.4 plus 3 squared times 0.3 plus 5 squared times 0.2 plus 7 squared times 0.1 minus the square of the mean, which was 3. Putting all of that into the calculator, 1 squared times 0.4 plus 3 squared times 0.3, 5 squared times 0.2 plus 7 squared times 0.1, giving us 13. We're taking away 9, which gives us a variance of 4 for that one. Okay, then it says 3 independent values of x denoted x1, x2, x3 are chosen. Given that their sum is 19, write down all the possible sets of values for x1, x2, x3 and hence find the probability that x1 equals 7. Okay, so we're thinking we've got 3 numbers added together to give 19. They're 3 of these numbers here. How can we do that? Well, 19 is pretty big, isn't it? If it was 7, 7, 5, that would do it. There's no other way there. It has to be that, or 7, 5, 7, or 5, 7, 7. That's our only options that we've got. And so, the probability of x1 being 7, well, it's given that this has happened. So actually, we don't need to look at this bit here. We know that one of these 3 things has occurred. Now, if we look at these 3 things, how many of them began with a 7? 2 of them. 2 of those out of that list began with a 7. So the probability of x1 being 7 is 2 out of 3. 11 independent variables of x are chosen. Use an appropriate formula to find the probability that exactly 4 of these values are 5s. Okay, well now we know how many trials are taking place. The number is either a 5 or it's not a 5. So really what we're dealing with now is a binomial distribution. There are 11 independent trials and the probability of a success of choosing a 5 is 0.2. So success is 0.2. And so we want the probability of this variable, let's call it y, probability of y being equal to 4. Exactly 4 of those chosen had to be 5s. That is 11c4 times 0.2 to the power of 4 times 0.8 or minus 0.2 to the power of what we were left with there, 7. That would be the other option. And we put that into the calculator. I can't remember how to do 11c4 on this, I don't think. Is it in there? No. That's not good. Prob, there we go. So we've got 11c4 times 0.2 to the power of 4 times 0.8 to the power of 7, giving us 0.111 to 3 significant figures. And there we go. And that's maths.